Welcome to the EEE360 video for lab number 15, the synchronous motor part 3. For this lab, we'll be using the following components. We'll be using the power supply, the AC voltmeter, the AC ammeter, the synchronous machine, the electrodynamometer, the three-phase wattmeter, as well as the DC ammeter and DC voltmeter. Here's a close-up of the synchronous machine and the electrodynamometer. We can see that there's a belt that interconnects the rotor of the synchronous machine with the electrodynamometer. And we can see here when we have the power supply to the electrodynamometer, we can read here at the bottom, that's where we're going to read the torque measurement because we're using the electrodynamometer as a constant torque load. And now the TA, Ji-Chang, is ready to make the connections for us. We're going to go from the adjustable AC power supply through the AC ammeter, from the AC ammeter to the A-phase input of the three-phase wattmeter. Next, we'll connect the adjustable B-phase output to the B-phase input on the three-phase wattmeter. We'll also connect the C-phase of the power supply to the C-phase of the wattmeter. Next, we're going to want to check the line-to-line voltage of our adjustable AC power supply. We're going to check the voltage between phase A and phase B. Next, we're going to make the connections from the output of our three-phase wattmeter to the stator windings of the synchronous machine. There's A phase. Now we're going to connect B phase directly to the B phase stator winding. Lastly, we're going to connect the output of the three-phase wattmeter, the C phase, into the C phase winding. Remember, it's very important that we connect the stator windings in Y, so we're going to go ahead and short the other side of our stator windings together. And now that we have our stator windings properly made on our synchronous machine, let's go ahead and connect our DC excitation. We're going to go from the fixed DC power supply through a DC ammeter. From our DC ammeter, we're going to connect that to our positive connection on our rotor windings. Then we're going to want to connect the neutral of our rotor winding to the neutral of our fixed DC power supply. We're also going to want to monitor the voltage of our fixed DC power supply. So we're going to go ahead and connect a voltmeter across each of the terminals of our fixed power supply, fixed DC power supply. Lastly, it's very important we do not forget to connect 120 volts. We're going to use our fixed A-phase power supply. We're going to connect that to the electrodynamometer. We're also going to connect the neutral point. And now we're supplying 120 volts to our electrodynamometer. All of our connections have been properly made. And now we're ready to energize our circuit. We're going to turn on the power supply and quickly adjust for 208 volts line to line, right there on the voltmeter as indicated. Now we're at 208 volts line to line. And now we're actually at 208 volts. Take a look at the watt meters. And then now we're going to supply DC excitation by closing the switch. And now we're ready to adjust for 9 foot-pound-inches of torque. Going to increase the excitation as we adjust there. And now we have 9 foot-pound-inches of torque. But we can see our watt readings are a little bit different. So we're going to increase our DC excitation until both of our watt meters are reading the exact same value. Now that that's set, let's go ahead and take a close look at all of our measurements. Watt 1 and Watt 2 have the same measurement, and they're measuring approximately 130 watts. And here we're going to take a close look at our DC excitation. We can see we have about 0.5 amps of DC excitation, as well as about 128 volts of DC excitation. And here's the current being supplied to our stator windings. We can see that that is about 0.82 amperes AC. Here's a close-up of our electrodynamometer reading. We can see that that is 9 foot-pound-inches. And now, students, it is your turn to do this experiment and more with the synchronous machine as outlined in your laboratory manual.